Good evening, everyone. Just to welcome you, my name's Adrian Winkles, and I'd like to welcome you on behalf of BCS Cybercrime Forensics, SG, colleagues from OWASP Cambridge, some of the other BCS groups that Margaret has mentioned. Welcome to our regular series, and of course part of the ARU's cybersecurity and networking research group as well. It's my great pleasure to introduce my colleague, Danny Werb, who's a lecturer from Canterbury Christ Church University, who's currently a PhD candidate as well as a lecturer, and whose research is focused on the user experience of digital forensic tools and those that use them, with a particular lens on the feasibility of using virtual reality to augment and enhance the practitioner's experience. And Danny also teaches on a range of cybersecurity and forensics modules for Canterbury Christ Church. Without further ado, I will introduce Danny, and over to my colleague, Danny, who will start his presentation.
Thank you, Adrian. Hello, everyone. Thank you for being here. It's very nice to be here, and I'm very honored that I can do this presentation with you all. So, I would like to present to you some of the research that I've been doing as part of my PhD. And this particular series is the digital forensics tool user interface broken? Now, what's the context here? Because that's quite important. So the context is, as stated by the NPCC 2020, that over 90% of all crime is recognized as having a digital element, resulting in the following challenges: sheer volume of data, complexity of digital examinations, and the need to maintain the legitimacy of the police. So when it comes to sheer volume of data, if you just think about all the data that you have stored on your devices, so for example, your phone, your smartwatch, your PC, your laptop, maybe even your car, all sorts of other electronic devices nowadays have the capability of storing data of in some way, shape, or form, and also different kinds of data. Some might just store GPS information, other might just store audio information. Again, different ones might store video information and audio. It's very diverse and it's very different. And it's all quite a lot if we take it all into consideration. Now, when the police usually goes along and takes someone's devices, it's usually everything: USB sticks, CDs, DVDs, hard drives, PCs, laptops, anything you can think of, they will probably take with them. And all of those devices accumulated will have a lot of data to go through. So we have the sheer volume of data itself. Then we have the complexity of digital examinations. So in the past, usually people would have maybe a PC, maybe a laptop, and that would probably be pretty much it from a source kind of view of what you could provide in terms of how much data you have. And nowadays it's just different, isn't it? Now you have mobile phones, you have your laptops and all that kind of stuff. Plus you also now have online storage, so cloud storage. You have webmail, emails, and so forth, right? So data of the person is now everywhere, pretty much. And so that means that the analysis is going to be rather complex. Sure, sometimes you can narrow it down to a few devices, but overall, it's more of a catch-all kind of thing. And then you start narrowing it down to the more relevant parts for the investigation. But it's still a complex examination that's going to take place because most people have their data across many different devices. And then, of course, there are other pieces of evidence that have to be corroborated and so forth. So it's all not quite as straightforward. And because of the sheer volume of data and the complexity thereof, the need to maintain the legitimacy of the police is of high priority because backlogs are a real thing. Backlog of data in the police is nothing new. It's not coming better. It's becoming worse actually, because the amount of data that is being generated is just becoming unreasonable in terms of, well, in terms of what the NPCC views it to be. So if we have a look at the 3V principle for big data, which is termed as volume, velocity, and variety, we can kind of see that these three principles have come out of big data itself, but one can also apply them to the data sets for forensic investigations, because that's what forensic investigations are. Digital forensic investigations, they have huge volumes of data, of course. So it's not far-fetched to take the 3V principle and apply it also to digital forensic data. And what we want to get out of all of this data is value. So volume, velocity, and variety. So volume is the amount of data, the velocity of the speed of which the data is generated, and the variety of the data that is being produced. We need to be able to extract some kind of value out of that, so evidential value. And that is, again, the big issue here. So one thing that seems to be generally ignored is the human aspect of dealing with all this data. There are a lot of people, of course, who go and say, well, we need better algorithms. Sure, we need artificial intelligence to help us with sorting through all that data. That is also true. But at the end of the day, a human being is still going to have to sit there and evaluate the evidence that is available. But so far, at least from my research, I can't really find anything that suggests that anyone is trying to make that better. So visualizations are mostly never mentioned in digital forensic guidelines and standards. And this is not just me saying that, this is also Guarino saying that in 2013. And Guarino also says that it will necessarily become one of the most useful tools in the analyst's box. So just being able to visualize data appropriately. Visual communication is probably the most efficient way into a human's brain, and this is not just something that Guarino says. This is pretty much, this is good knowledge that I think makes a lot of sense, and one couldn't find plenty of other evidence for that. But again, visual information is not something that is used a lot, or not properly, I should say. And the reason for that is because of the way we seem to be presenting data. So in digital forensics, generally what we get to see is this. This is a well-known tool. It's EnCase. It's a digital forensic suite that is used by investigators in order to, and analysts in order to extract data and analyze it and so forth. Now, if you have a look at this user interface, you'll probably, unless you're used to EnCase, you'll probably find yourself a bit lost because of all the UI elements that we have here. What do they mean? How do they function? And it's not necessarily straightforward to work with these pieces of software. EnCase, of course, not being the only piece of software. There are also others like FDK, magnet forensics, and so forth. But overall, the general view of what the programs look like is this here, this EnCase kind of example here. This is what a digital forensic investigator usually has to look at. It's just tables and fields, text fields, hex fields, and some trees, and then some picture galleries and so forth. And it's not always easy to understand how this data is linked, for example, or how to use it properly in order to link it. So there's bookmark functionality, for example. So an investigator can bookmark which things are important, and then they can collect these bookmarks together in order to go through the list. That's fine, but again, there is this element of, there is not really a relationship here because it's all very flat, and there's not necessarily an understanding of how the data actually links to each other. So another example, for example, another example is Semantics 21. This is a program that is used for grading usually. So grading is the process of giving a value to a picture and how difficult it is to process, as in, is it, how should I say, is it a picture that shows graphic content, really graphic content, or is it a harmless picture? And so there are different grades that are applied to each picture. And although there are a lot of automated processes to do this without a human being having to be involved, unfortunately, there are still times when a human has to sit there and go through picture galleries that have been extracted that are unknown and that cannot be analyzed by an algorithm. And so they have to do it by hand, or they have to double check it. So Semantics 21 is one of those programs that will allow you to do that. And again, here it's mostly a picture gallery application. And what we see here is the pictures are all presented in a 2D fashion, of course, in a picture gallery fashion where you can scroll down and you can zoom in and so forth. But it's all, again, the approach here is to try to make it immersive, taking away now the context of this, but the idea behind it is that it's immersive and that the observer has an overview of what's happening and what the data set is. And that's fine. But again, it's probably not going to be helpful when it comes to then linking this stuff or this evidence to other pieces of evidence, or to take a better view of the overall case. Here is an upgraded version, Semantics 21, a little bit more friendlier for the eyes, perhaps, because it's darker. And there are a few more options here with the updates. Just wanted to show that it's there are things happening, of course, in the 2D world of presenting data, but again, it all stays on a 2D canvas. And then, of course, we have the biggest one, and that's X-Ways. X-Ways is I guess one could call it probably the jet fighter under the digital forensic suites, because it can pretty much do anything an investigator would want. It is incredibly functional. It has a lot of very excellent ideas behind it, and it executes them rather well for the most part, but it is incredibly difficult to use and incredibly problematic to understand. So a lot of the, we'll get to that later, but a lot of the investigators that I have spoken to like X-Ways very much because of its capabilities. However, they find it incredibly difficult to use. And of course, one could make the argument that that's on purpose in order for them to sell, you know, training courses and so forth to law enforcement, sure. But there is, from my point of view, from an academic point of view, there's no need for this. Why make it more difficult, right? I mean, sure, there's of course the commercial side of it, but why does it have to be like this? But let's leave that just aside quick and just focus on the fact that this is a 2D interface that is very complicated looking, and it looks not much different from the other interfaces that we have seen. So we can start seeing a pattern here where we have usually this 3-pane layout on the left-hand side, some kind of tree view, on the right top side, a list view, and then on the bottom, we have some kind of gallery or preview or stuff like that. And that's a layout that we've been finding throughout digital forensic suites all over. But the question here is, can we do better? And the reason why I have this particular picture here is because I found one of the things that Jurassic Park was doing was to surprise people with perhaps a alternative way of looking at a user interface. It was very, very brief, and maybe most people didn't even notice it, but this particular character here, Alex, she has to go to the systems of the Jurassic Park computer and is going to try to control it. And she says, it's a Unix system, and I know this. And what she actually looks at is this here, which is the a file system navigator, FSN, which was developed by SGI, which was a company that provided Unix workstations and operating systems. And one of the things that they wanted to do to show off the graphics capabilities of the workstation was to demonstrate it using this particular piece of software here, the file system navigator, which showed the file system on the disk in 3D, and gave a few hints at how directories are structured and the sizes of files and so forth. And that's all great. I mean, this is a good example of how one could do it differently by providing a 3D experience. However, the problem again with this is not only is it very old, sure, but and the graphics look a bit, not pretty much outdated, of course. But the bigger issue here is, again, it's a 3D interface in a 2D canvas. So 2D canvas meaning your screen. You just look at your screen, right? You're not immersed by your screen. It's something that you can look at, you can look away, and then it's gone from your field of view. But it is there if you want to look at it. And in this particular file system navigator, it has a 3D representation of the file system. But again, it's just a representation that you can just look at. You're not immersed in it or anything like that, right? So, thanks Jurassic Park for that idea. Pretty good. Unfortunately, it never went anywhere. I think File System Navigator was a one-off thing. And so the question now is, can we actually do better? And science fiction, sure, always can. And science fiction has always been a great inspiration, of course, just like science has also inspired science fiction, of course. And so when I started my research, when I described what I was doing, people were like, oh, this is what you're doing. You're basically just doing Minority Report, right? And that is not true, of course, because sure, there are similarities with Tom Cruise waving his arms around and moving the things on a transparent screen in his viewport, and then interacting with them in some way, shape, or form. But again, this is if you think of it, it's not much different from what we already have, except that the screen that Tom Cruise is standing in front of is huge, first of all. Second of all, translucent or transparent even. And the interface is one that reacts, of course, to what he's doing with his glove. Yeah. And it's gesture-based. It's a gesture-based interface, which is not really anything new, but very difficult to do. And of course, this kind of screen thing that Tom Cruise is working with wasn't really ever developed or anything like that. But this is what most people think of when they hear about my research. So that is one thing that I need to get out of the way because it's not Minority Report. And so we are left with, well, what are the alternatives? Well, if you think about what the marketing teams do, for example, Magnet's marketing team, Magnet is a well-known forensics company, and they also provide software just like X-Ways or NKs or FTK. And they have apparently a very good marketing team because they want to use some very impressive visualizations to sell their product. So let's see if I can play this.
Criminals leave digital footprints behind, and those footprints are spread over their devices. Magnet Axiom provides comprehensive and powerful analysis of multiple devices, all in one case file with purpose-built reporting tools. Uncovering evidence from sources like computers, mobile phones, cloud services, and vehicles is painless with Magnet Axiom's easy-to-navigate user interface. Plus, with Axiom...
Right, let me just stop there quick because I've got something to say here. Have a look at that quick, that Magnet Axiom advert still right here. So we have this guy sitting there in front of this tiny little laptop, and what the marketing group is trying to make us believe is that this is what is supposed to attract people to Magnet, this idea that there is some floating interface around him, even if they're not taking it horribly serious. The question is, why would you do that? Why would you provide a marketing ad for an interface that doesn't exist, and the real interface actually looking much more, well, common or much more boring. So we've already seen some of these floaty elements in the advert where certain devices are connected, like the mobile phone is connected, and there's a bunch of other stuff connected, and there's some floating blue lines going around trying to help visualize the connection between these devices and the data flowing between them. And when I saw this advert, I had a giggle because I thought to myself, well, this is perfect to show what's actually wrong in that sense with how this is presented, with how the digital forensics companies like to present their products, because everyone would like to have an interface like Tom Cruise has, right? Where you have all the data floating around you and it's much easier to grasp and so forth. And then you have Axiom's team here, marketing team here, doing this advert where they're pretending or trying to present it in such a way that it looks much more attractive. So let's just finish this video.
Axiom's analytical tools such as Media Explorer, Timeline, and Connections.
Right. Okay, I stopped there a little bit. Here. So we've got some timeline information here, and we've got some right. So the timeline information here, and now if we look at that in particular, right, we can see that it's not at all this whole floaty little interface that you were showing, of course, because it's not, you know, it's a marketing gag, surely. But we still have the same issue with this fantastic advert and Axiom, which is it's just a 2D application. It's not doing anything different from X-Ways.
Line and Connections. You can surface, tag, and report on evidence with ease.
It's not doing anything different from Semantics 21 in that case, when it just comes to gallery view, or X-Ways gallery view, or in cases gallery view. The functionality is always the same. So the question becomes why bother, right, with these floaty little interfaces in their marketing guide?
To get the most comprehensive view of a criminal's digital footprint, try Magnet Axiom today.
Right. So just to demonstrate, right, they're not, they understand that there is a need to attract people by making visualizations nicer looking. That's the thing that marketing, of course, does. But I think it's a bit dishonest that they would place that kind of visualization in an advert when clearly the actual interface is much less exciting. But anyway, let's move on from that. That was just to demonstrate that actually marketing teams know what attracts people, and that is good visualizations, right? So my idea is based on the fact that we humans have a lifelong experience with spatial understanding and handling of objects, right? And we understand them without effort, and we understand their nature usually without having to think much about it. So everyone knows how a door works, how to open it, how to close it, what a table is, how to use it, what a chair is, and so forth, right? And we have an understanding how to use these objects and make them useful to us, right? So I don't know, I need to change a light bulb in the ceiling, but I don't have any ladder, but there is a chair. So I just take the chair, stand on the chair, get to the ceiling, replace the light, and so forth, right? It's easy for us to understand how we need to use objects, right? But we don't do this with computer programs. We don't do this with certain user interfaces. We treat user interfaces like something that is separate from what we understand. We have to start going into a more abstract mode of thinking. And that is where I think the issue lies with digital forensics in particular, because of the amount of data and the complexity of the data that the investigators have to deal with. I think just having to engage in this abstract thinking of where these various different artifacts are, digital artifacts are, and how they interlink with each other doesn't work anymore in a 2D space. So what I'm trying to find out is immersion using virtual reality, for example, something that makes sense, right, to forensic practitioners? So treating artifacts as real objects. Now, When I say real objects, I don't necessarily mean real representation of the objects. I mean, how would you represent a Word document other than a pile of paper, perhaps? Or how would you present GPS data on a map, perhaps, right? How would you present a picture? Well, again, you can show pictures, of course, on a wall and so forth. But those would be things that you could understand how to handle, because they are very similar to the things that you're used to in the real world, right? So the idea is then also to find out, not only is it useful, but how is it useful? Does it reduce the need for abstract thinking? And does it also reduce cognitive load? And the cognitive load part, of course, is that part where we have to strain our brain in order to understand if the data that we're looking at and how to interact with the user interface in order to get at what we want, right? So what I'm trying to do is to find out how we could do this better. And at the moment, my pursuit is using virtual reality. And now the question is, well, how did I get to that, right? How did I get to that idea? And the idea came from playing games, video games, in particular this game here, which is called Heavy Rain. It was a game in 2010 released by Quantic Dream. And it's a story-driven game where you follow various different characters. And one of those characters, it's based around a ongoing crime, basically. And I'm not going to spoil it for those who haven't played it yet. And one of those characters is this person here, FBI agent Norman Jaden. And as you can see, he sits in a office, an abandoned looking office, the kind of office that no one wants to sit in the police station. And he's sitting there at a table that is completely empty. There's nothing there. It's completely devoid, no computers, nothing in front of him other than an empty cork board. And he has these glasses on. And he has a glove on, much like Tom Cruise did in Minority Report, right? So the interaction here is that at this part in the story, you sit down with Norman Jaden as a character, and you activate these goggles that he has on his face, these glasses called the ARI system. And what happens then is that it doesn't matter where Norman is. He then is transported into this other world through the glasses that he's wearing. He's seeing a different world in front of him. Now, of course, for the benefit of the player of the game, we see it from a different angle. The player sees it from the angle as if they were with him in that space. And so while he might be staring at just screens in his glasses, of course, like you do in VR, we are looking at the scene where he's in as if we were in there with him, right? So, don't take this as this is what it would look like at all. This is just an example. And the reason why I'm showing you this example is, first of all, it was the inspiration for my research idea. But second of all, the prototype that I'm working on isn't quite ready yet to actually show anything off. So I thought perhaps instead it would be better to just show off the inspiration first. So this is what happens when Jaden puts on the glasses and we get to share this world with him. And one of the first things we get to do is we get to choose a scenery. We get to choose where he's going to work. And we can change the scenery by activating one of those bubbles. And there are different sceneries. So we went from a forest to Mars. There's also a mountaintop and an aquarium, and some. I think that's pretty much it. And the idea behind this came actually. So the game obviously came out in 2010, but when I did interviews with practitioners, they said that their investigators would very much enjoy it if they didn't have to sit in a dark corner of the office and stare at a screen with not much else going on. So I thought this is amazing because if I can get a VR system to look any way the practitioner prefers, in order to make him feel comfortable, or in order to make them feel comfortable, then yes, why not? That can surely be a good thing, right? So that is one of the capabilities then that we would have, of course, using a VR system, is to transpose the person into an environment that is more relaxing for them, perhaps. So defining the scope, what I'm trying to do here is focus on the investigation itself, not the analysis part. The analysis part, I don't think can be optimized in the sense of how the user interacts perhaps with it, because a lot of the analyst part is automated. So usually the analyst will sit there, take the hard drive or the image of the hard drive, will run a bunch of automated tasks across the hard drive that will pull out all sorts of information, pictures, databases, browsing history, and so forth. And usually those tools do a really good job at pulling out all that information. And then, of course, the investigator is usually the person who then goes through what has been extracted by the analyst and needs to see what is available and if it is something that is useful to the investigation. Yeah, and that's the part that I'm focusing on, because as I said, I don't think that there's much that can be done in terms of user interface for the analysts, but certainly for investigators, which is also quite important because I've been told multiple times by practitioners that the investigators are generally not very tech savvy. These are people who don't work in computers or in anything remotely remote to computer science or computing or anything like that. And they just want to get the information that they're after. And one of the other things that is important is to reduce the learning curve then for these people, because the practitioners I've interviewed, again, they've said that it is very problematic sometimes in trying to teach the various different viewing programs that they have to the investigators, because not all investigators will have knowledge of the programs that are used in order to look at evidence. And so they have to spend time and they have to spend resources in training these people up. And it's not going to go away. I mean, that's just something that's going to forever happen while digital forensics is being used by investigators, of course, to do what they have to do. And we want to reduce that. We want to reduce the learning curve, perhaps, and make it easier for the people who have to look and go through the evidence that they have to work with, without having to worry about the program that they're working with. So not having to remember which menu item to click to get somewhere, not having to remember where the context menus are for certain things or which buttons to press and so forth, but just being immersed in the evidence that they want to see and being able to handle the evidence in a way that makes sense to them, that works for them in a more natural kind of way. So that's the scope of the research. And the background is that I teach digital forensics tools. And every time I teach digital forensics tools with my students, there are always user experience issues. So students will find it difficult to find certain elements of a user interface of a different program. They will find it difficult to understand which steps they have to take in order to arrive at a certain outcome. They will not necessarily find it easy to understand which programs should be used for which type of artifact and so forth. So there are plenty of user experience issues that need to be resolved. And it's also very much clear that the user interface design is not a priority for manufacturers. As we've seen earlier, they all pretty much follow the same pattern. And sure, one could make the argument that the reason that they're following that same pattern is because it's a pattern that is working in inverted commas. That is not an argument I accept, because I do think that it's a bit lazy and that there is no innovation behind it. It's just something that they do because it works so far, but it's not making it better. And the goal surely would have to be to make it better for the investigators or the people actually using the software. So user interface design is clearly not a priority for manufacturers. Like if you compare that to how operating systems, for example, develop, just Windows 10, Windows 11, this difference there, or the differences between various macOS versions, or even if you just look at the landscape in Linux land, there are just so many different ways of doing user interfaces. And yet digital forensics just keeps sticking to the same old stuff. And I understand, right? You know, people don't necessarily want to have to learn new things. But then my question is, why are you developing a system or a user interface that is inaccessible or difficult to access without having training and so forth? So the user is then locked into the design decisions of the manufacturer, right? There's no way of getting out. There's no way of moving things around in such a way that they make sense to the investigator. They have to pretty much adhere to what the design decisions were when the digital forensics suite was written. And yes, digital forensics practitioners generally have a lot of screens on their desks, usually at least 3, maybe even 5 or 6. And they have to do this in order to spread information around. So some piece of information needs to be on that screen, the other piece of information, like a picture gallery, needs to be on the other screen. Some tables need to be on the screen on the bottom left, and so forth. So you can already see that people organize themselves, and they need space in order to do this organization, right? And at the moment, they solve it by putting various different parts that they're interested in on different screens. So they have a way of fencing off that information, and they have it in their brain. They understand where the location of that information is. And so they just look at it on that particular screen where they put it on. But again, that is still being locked into the design decision of the manufacturer and not being able to actually work with the interface in such a way that it makes sense, natural sense for the user. So then displaying and organizing data is difficult on 2D canvas, right? So that's what I just said. Literally, it's using as many screens as possible in order to spread out the information so one can work with it without feeling cramped. The next one is cross-correlating artifacts is hard. So trying to find how pieces of evidence or artifacts are related to each other is difficult on a 2D canvas. Yes, you can do bookmarks. Yes, you can do favorites and stuff like that, but it doesn't give you a spatial awareness of how things are linked to each other. And so effort and patience is required in order to use and understand these user interfaces. So my argument is that perhaps a 2D paradigm is not good for this, not for this type of work, and it can only take us so far. And as the amount of data is growing and the complexity is also growing, I don't think that we can continue for too much long. Not saying that it's going to like collapse or anything like that, but I think there is a limit to that is going to be hit when it comes to what these people can do on a 2D screen. So of course, I didn't just come up with this and then thought to myself, ah, this is fantastic. I'm just going to talk about it without having any backup. So I asked professionals, I asked actual practitioners who were also from around Europe. So 5 from the United Kingdom, 3 from Norway, 2 from the Republic of Ireland, 1 from Belgium, and 1 from Germany. And they all said the same, and they pretty much agreed. I've interviewed these people, and the interviews were different lengths, anywhere from half an hour to 2.5 hours. And of course, I've transcribed all the data and did a thematic analysis. And from the thematic analysis, I extracted the following topics. So the first one is the importance of visualizations investigations. The second one is ways of overcoming physical screen limitations. So the practitioners themselves were talking about how difficult it is to actually handle all of the information that they're working with the screen space that is available to them, even if they have multiple screens. Which also links to number 3, which is organizing artifacts from various sources. Again, there are limitations when you have to then pull in information from, I don't know, CCTV or different cases and so forth. So it becomes all very crowded, very difficult, even on multiple screens. And that makes it then also difficult to apply investigative curiosity. Now, what is investigative curiosity? Well, the idea behind it is that you have a hunch, basically, a bit of a Columbo moment, where you think, there's this that I need to look at, and maybe it's going to lead to something else. And in order to do that, you have to have all the information available to you, but you also have to have it available to you in such a way that you can quickly see what you are looking at, what you have, and what you can work with, and how it all might link together. And you should be able to dig down and do hypothesis testing with the data set that you have, with the artifacts that you have. And so from that then comes getting and presenting the big picture, which is where not only does the investigator have to understand what's going on in their case, of course, sure, but eventually it comes to the point where they have to present this either to a superior or to a court or whoever needs to have a look at this. And generally what they do is they have to print out Excel tables and Word documents, and it's all hundreds of pages of evidence, perhaps even thousands of pages that have to be presented. And so you have people flicking through that, through those pages. It's all, sure, it's possible to digest it, but it's not optimal. It's not the best way of presenting evidence. And I've had regular complaints by the practitioners that I've interviewed about the fact that it's difficult to present the big picture of a case to even a colleague sometimes. So there is, again, something that needs to be done there, right? And this is something I think that can also be addressed by a system that allows for digital forensics investigations in virtual reality. So I've taken the various different thematic analysis points, and I've attached them to clips from Heavy Rain, just to kind of give you a feel of what is meant by it, right? So if we go here, this is the importance of visualization, right? What does it mean? Why is it important? So if we look at Norman here, he opens a box, a symbolic box that shows the set of evidence that he has at that point in time, which is just a origami figure and some tire tracks and a orchid. And those are the pieces of evidence he has to work with at the moment. And he can interact with these elements. They float around in the air. He can move them around just the way he needs them. So the idea is that we need a different way of visualizing evidence, artifacts from digital sources, so computers and so forth, right? So that is one of the main things that I'm also focusing on. What does it have to look like? What do these artifacts have to look like? This here is a concept art of mine where I'm currently developing how to interact with the system. And maybe you can see that the gestures are nothing new. It's not something that I'm inventing from scratch or anything like that. Gestures like these are common in gesture-based interfaces. It's just that I'm trying to figure out which gestures would apply best to a digital forensic investigation. The next one is overcoming physical screen limitations. And here we can see that Norman is looking at one particular piece of evidence. And while he's doing that, you can see, of course, it's mirrored so that we as a user can see, or the player can see what he's actually looking at. He gets contextual information just like that in the corner of his eye without having to look for any particular box around him or anything like that. So overcoming screen limitations just means that the information is always in your eyesight without having to switch around screens or anything like that. The other and more important, the one focus that a lot of investigators wanted to have was a timeline, yeah, because it all starts with a timeline, really, in investigation. You need to know when things have happened. And so why not create a timeline? And this person here in the middle, that's the user with the VR glasses on, Why not focus on something that allows us to walk around the timeline? A timeline would be fed by already existing analysis tools that would then be parsed into the system, into the VR system, and the VR system builds from those elements the timeline and the evidence that has been extracted, and prepares it in such a way that it can be interacted with by the user. So why not have a timeline that you can walk around, or perhaps spin around, or fly around, and then you not only have an understanding of when things happened, but maybe even how they are connected in a more spatial kind of fashion. So that is one of the ideas. And then organizing artifacts. This is a bit more classic, I suppose, where he pulls out a file cabinet, a virtual one, and these are just literally files that have some information in them that he can view. And of course, my system is not going to look like that, but it's just a neat idea that you have a virtual file cabinet and you can flip out your files that you want to have a look at, and then you can just inspect them, and then you can move them away if you wanted to just by swiping your hand. So that's an interesting interaction with that system. And here is another piece of concept art where the cases are grouped in, I don't know yet, orbs perhaps, or something like that, where the sources for a particular case are encased in orbs. And one can, from a high level point of view, the person here in the middle again, can see what is available, which sources are available, what might be in those sources, you know, just like a cursory glance at it basically. And then if the user wants to, they can dive into any one of those orbs and work with the evidence within them, and then get back out again, and so forth. And therefore being more immersed into the actual evidence collection that is available to them. Then we have, of course, investigative curiosity. And here, this is one of the things that Jaden can do, which is take evidence and throw it at a map, and the map will then show where that particular piece of evidence has been found, or where other occurrences of that evidence have been found. In this case, it's just the orchid, and somehow in the game, they've managed to measure the pollen count, and that's what you're seeing basically on the map. It's the pollen count of that orchid, so we can see where that orchid is detected on in the city and so forth, right? But the idea behind it still is that you can start cross-correlating data, and that you can start looking at how things match up. Like, for example, a lot of pictures have EXIF information attached to them, so GPS data might be some of it. And you could take, why not be able to take that GPS data, extract it from the picture, look at the picture in your VR environment, and then if you would decide to do so, you could say that you want to visit that location in VR, and there is such a thing as Google Earth in VR, so you literally fly around like Superman, and you can visit various places on Earth. So, and that is something that you can interface with, and why not be able to take that information, say that you want to go and visit that place, and you tap on it, and you're in a bubble that will allow you to inspect the area that that picture has been allegedly taken. So that is something that would be very easily done, and probably quite natural from an usability point of view. Here again, some of the details of those files that Jaden pulled out. And then we have the big picture. The big picture is just cross-correlating all that information again, and then finding where the victims are on the map, or where they have been located on the map, to try to figure out some kind of pattern and so forth. Yeah. Again, this is obviously just a game, but it's supposed to just demonstrate that, you know, getting a big picture as of where or how things happened, or you know, patterns have emerged and so forth. How it's important to get that by just observing visual information for the most part. The other final thing was link analysis that I wanted to show off here quickly. Link analysis is particularly important also in investigations. I even spoke to one of the people who was involved in creating the whole concept of link analysis for law enforcement. And we spoke about, how it came to be and stuff and how it works. And it's very important that this is something that investigators can do. And why not then use link analysis in an environment that literally has no walls and no limits? So you can, create your links just the way you need them without having to worry about the surrounding furniture, for example. So the ideas are so far that I'm considering using hand tracking for accessibility. So instead of using VR controllers, there is something like motion leap, which means that the VR system can recognize your natural hand gestures and use them instead of having to use a game controller, which would make it much easier, of course, for those who need to use the system to get used to it. Another thing that has been raised by the investigators that I've been, or practitioners that I've been talking to, was gamification. So the idea maybe to introduce the person who's working with the system by just giving them a basic gamification tutorial on how to interact with objects. And then finally, considering a type of skeuomorphism for organizing and interacting with the objects. But skeuomorphism is one of the things that Apple introduced early on when they developed iOS, which was in order to help people transition from the real world into a more, in double quotes, virtual world. They would make certain applications feel or look and feel like the real thing. So the early iOS address book, for example, looked very much like a real address book. It was leather bound. It behaved very similarly. And that was supposed to help people transition over from real world objects into virtual objects. So there is a chance that I'm going to be looking into using skeuomorphism to make it easier for people to work with the various different representation of digital artifacts. So conclusions, well, immersive interfaces have neither been suggested nor implemented for this type of workload as far as I'm aware. So this would be the first, I think. All practitioners that I did talk to liked the idea a lot and would also happily test the system, which is great for me as a researcher, because it means I'd have, of course, less worry when it comes to trying to find people to work with and testing this. And I do think that VR should be explored as a feasible solution to digital forensic investigations. And the people who I've spoken to, the practitioners, also said that it seems like a very good idea to at least try and find out if it's something that would work for them. So what are the current goals? The current goal is just trying to answer the question, is immersion useful? Is it more fun to use? Is it more intuitive to use? And does it help save time or speed up an investigation? And does it help reduce cognitive load on the investigator? Those are the questions that I'm trying to answer. All right, well, that was that. Thank you very much. Any questions or comments? We already talked about that in the chat box. I have references here. I'm just going to click through them really quickly. And that is it. Thank you very much.